Okay, here we go. Kinesiology 230, Chapter 1, Presentation 3. We're still talking about the myofibril, and the sarcomere now comes into play, and we're going to do a little bit of a quick review here. So we talked about this pretty much in depth here. We talked about the muscle belly, the endomysium, the paramysium over here, and then the epimysium, the paramysium, and the endomysium with fasciculus, then the sarcolemma. And so we've looked at it in terms of like big picture with gross motor all the way down to sarcoplasm and down to the myofibril. If we take this even a step further, we're talking about this first square, we've gone to the second square, but now we're going to get a little bit deeper into the myofilaments, the actin and the myosin, which is really where the muscle contraction happens. We spent some time here in the sarcolemma, talked about how the sarcoplasm is like a watery solution, and then you have mitochondria, which is or are the purple over here that is where the ATP is produced, and then the sarcoplasmic reticulum is what stores the calcium. That's this yellow area here, and you have these transverse tubules, which are transverse to the actual sarcolemma itself. And I went into a little bit of a conversation regarding ATP down here. Get my face out of the way. How it's created in the mitochondria, found in the sarcoplasm, et cetera, et cetera, et cetera. Releases calcium into the sarcoplasm of the cell where the action potential passes through the T tubules, which is up here, which we'll get into that, trust me. So if we take this a step further, now we've taken that diagram from before, this one, and we've gone all the way down to this little window here, myofilaments. So the sarcolemma to the sarcoplasm to the myofibril, and now we're in myofilaments, both actin and myosin. If we look at this kind of on the bottom here, muscle group, muscle belly, fasciculus, to the sarcolemma, to the myofibril, to the myofilaments, both actin and myosin. That's kind of something, if I were you and you wanted to get into this, to the industry, like a fitness or a movement practitioner, you probably want to rewrite this thing about 1,000 times in a notebook somewhere just so you never forget it. So the myofibril itself is housed in the sarcolemma. We know that the myofibril is made up of myofilaments. Now think of it myo, right? We're talking myo muscle. We're going from fibril down to filaments. You can think of like a hair filament or just a filament, like a very small string. That's what you have to visualize when you think filament. You have actin and myosin. Actin is the thin, myosin is the thick. And these are really where you have like the functional contraction happen, right? These make up the basic functional unit of skeletal muscle, the sarcomere itself. And you have sarco that we saw, it's Greek for flesh, mere meaning part. So sarcomere is part of a fleshy component. Excuse me, should put that up there so you know exactly what we're looking, the myofibril down to the myofilaments. Okay, so this, if we take this a step further, where the square is on the screen right here, and you have the myofibril and then the myofilaments, if we take that a step further, what we're looking at is this myofibril right here, and you end up with this. Now this is a number of myofibrils kind of bundled together, excuse me, and within each one you have this. Now, this is the sarcomere, and the sarcomere is subdivided into different bands and zones, which can be incredibly confusing if you're not careful, but the bands and zones have their purpose. The Z line is right here, here's one, and there's another Z line here. A Z line delineates the beginning and the end of your sarcomere. Everything happens within the Z's, or everything happens between the Z's. Zwischen means between. I band, which is this guy right in here, this kind of lighter color, is isotropic. And then A band is anisotropic, which is this blue over here. And then you get the H zone, which is heller, meaning brighter. That's the H zone right here, which is kind of smack in the middle. And then you have M line, which is mitral or middle. And so you have an M line as well. So what happens is you have this I band, A band, M line, Z line, H zone. It was all based off of German, right? So I mentioned before, you have different regions that were learning the human body, they learn the human body at different times. And so like this is a great example of how when my scropopy, Jesus, I can't even say microscope, comes into play, you end up having the ability to look at a much smaller and smaller and smaller area within the muscle. And this happened in Germany where they found this. So that's where the names came up from, Zweichen, et cetera. Now, some of them are a little bit of a blend of from other regions, but really what you're looking at here is where the terminology comes from, or what the terminology is kind of dictates where it came from. Okay, so let's just do a little vocab refresher here. Epi, upon, over, or outermost, like an epipin. Remember that epipin in the thigh. Endo, which is the innermost, so you have an E and an E for your layers, and you have one more in the middle there. That's your P, peri. So you have epi, peri, endo, meseum, muscle, sarco, flesh, and then you have mere, which is part or segment. Then you have iso, which means similar or same, and nesio, different or dissimilar, tropic, attracted to. So like when we look at this and you see anesiotropic, the A band, the anesio tells you it's different, dissimilar. The iso tells you it's similar or same. Got it? So let's go ahead and just jump into this a little bit further. We'll go ahead and use some of this terminology to kind of help us get through some of the things we're talking about here. Endomysium, paramysium, epimysium, cool, sarcoplasm, sarcolemma, sarcoflesh, myofibril, myofilaments, myo meaning muscle, excuse me. And then you have, mesium, as you see over here, MYSUM, mesium meaning muscle as well. So, you look at this and you can start to kind of dissect the terminology that they use for all of this. And if we kind of break this out, let me get this guy out of the way here. If we look at this in this presentation, I took it from another class, but it works great. You have the Z line itself is Zweichen, or between, and everything happens in between the Z lines. And let me get myself out completely out of the way up here. And again, so you have a Z and a Z, and in between those Z's is where all of the muscle contraction happens within the sarcomere itself. All right, so then you have the I band, the A band, the H, the M. Okay, let's look at that, right? So in the I band, the isotropic, you have these orange lines. Just real quick, are they thin or are they thick, right? Just kind of relatively speaking. Well, they look kind of thin. And then it becomes a conversation of, if they're thin, are they actin or myosin? If they're thick, are they actin or myosin? Well, at this point, they look pretty thin, and as a result, you're pretty sure they're actin, but let's kind of see how this plays out. So we have these thin actin filaments, and on each side, by the Z, you have the I band. Now, the I band denotes where you have actin and actin only, and then you have the Z. So Z, I, you have an open space, then an I, then a Z. This is all actin filament here. The I denotes actin filament only. You'll get to this, don't worry. Z, and there's your Z. Next slide. We then jump into, we have our Zweichen, we have our isotropic, and now we have a nesiotropic. So if we look at this again, we have our thin lines. Now we have what look to be thicker lines. And with the thicker lines, let's just go ahead and say they're thicker, right? Now, does that mean they're myosin or actin? Well, if they're thicker, they're going to be myosin. And you know that just from our conversation of being thin is actin and thick is myosin. So let's go ahead and jump into the next one. So with the myosin represented, it's kind of easier to see the different regions, and one can understand how through a microscope in the 1920s or whatever it is, they might look at this and be able to, and that's why they gave them particular names for different regions. So the A band itself is this. It's the myosin from end to end. And so we go ahead, here's our myosin again. And within this region right here, you have just myosin. You don't have actin and myosin, you just have myosin. And within that, that's called the H. And it's called the heller meaning brighter, because when they looked through a microscope, they saw this and it was brighter, even though it's thicker lines, because it wasn't thick, thin, thick, thin. It ended up being a lighter color here than it was over here because of the Z in the I. So just remember, H. Heller is in the middle where the myosin is. That's that region. And then we go ahead and look at this a step further. This line down the middle, oddly enough, mitral is middle. So when you look at this, you know H is nothing but myosin. M is right down the middle. Your Z's are your bookends on either side. I is just actin, actin only. And then your A band is here from end to end. Got it? So let's go ahead and take a step further here. When you get to, when you get into the book and you start reading, I would, again, much like I said before, this might be one where you start to kind of write down these passages and kind of write them over and over and over again. But I'm just going to reiterate and revisit this. We started off with muscle group, muscle belly, fasciculus, sarcolemma, to myofibril, myofilaments, actin and myosin within the sarcomere itself. All right, guys, with that, I'm going to go ahead and just break off, and I'm going to move on to the next presentation. You got it? Good stuff.